If I remind the Frobenius mapping, the Frobenius mapping originally is a mapping function that it maps from a to the fifth power, but this assumes that this a is construct with a extension field based on prime field. That's why it looks like that, f p to the k. But the problem is what we have just before is like now we need to this Frobenius mapping on extension field that looks like something like this, which is constructed using a torus of extension field. So this fp to the n is a extension field based on prime field, but the fp to the n is the extension field based on the another extension field. And in that case, we have two different Frobenius mapping. One is relative Frobenius mapping, which is a new notation kind of. So we can denote it as a phi sub rel, and the element of this A is now belongs to the extension field. It's different from the original absolute Frobenius mapping, which was prime field. So in this case, because the order of this extension field is p to the m, so the relative Frobenius mapping will map input to the p to the nth power. So unlike the absolute Frobenius map, yeah, the property that relative Frobenius mapping has, if you have any element belongs to this f to the f sub p to the n, the value will be preserved. Originally, the x, if x is part of prime field, the value is maintained, but the difference is like now relative Frobenius mapping maintains the value whenever value is part of this extension field in the middle. And then the relative norm definition also becomes different. Now the relative norm of A will be defined as this equation. So instead of like A times A to the P times A times P to the 2 or P square or P cube, or instead of that, now we have this series of powers A times A to the P to the M times A to the P to the 2 times M, blah, blah, blah. That's the new definition of relative norm. And the property that this relative norm has, like similar to absolute norm, now the relative norm will give us base field instead of base prime field. Absolute norm will give us base prime field, but relative norm will give us base field. And you can also compute the absolute norm using this equation, and I will unfold this equation with this. So first, the first step is like you need to compute relative norm based on this equation first, and then using this, you compute absolute norm with respect to f to the p, that will be like b times p to the p times p to the p square, blah, blah, blah. And if you merge all of them, then you get this, which is absolute norm. So this is the difference between relative norm from absolute norm. And I also give you some practical example that the field that we have a problem with. So Merton 31 Hurt extension field will be, this guy will be construct from Merton 31 quadratic extension field, which is construct from Merton 31 prime field. So in this case, relative norm can be computed as follows: A times P squared, and base norm will be based on this b computed as b times b to the p will give us the absolute norm. So in that case, Frobenius-based inversion also need to use relative norm instead of absolute norm. So in this case, so if you go back to the inversion in just the extension field, this guy was the absolute norm, but instead of this, we compute relative norm, and then the rest of the process will be same. So R is computed as same, and the other expression also, yeah, maintain same. So only the difference is like how you compute the norm in that set, in that part. Yeah, then if you fix it like that, then the extent Frobenius-based inversion in case of Merthin 31 quality extension field works correctly. So yeah, the unit test passed. So yeah, that's all I wanted to say in this session.